Okay guys, welcome once more to another video again in my channel. So in today's video we will be looking at the advanced level mathematics June 2021 question 2 of paper 2. Okay, so we'll be looking at the solution. So please I recommend that you should like the video, subscribe to the channel so that whenever new videos are uploaded you will be the first person to find them. Okay, or you'll be the first person to see them. Okay, so as displayed to you on the screen, you can follow me on the YouTube platform via Mathematics Dreamland for Africa. So that is actually my channel name. So if you go on YouTube platform and then you just type, either you type Mathematics Dreamland for Africa or you just type MDLFA, so you can find me there. And equally, you can also reach me on WhatsApp via the telephone number displayed to you on your screen. Okay guys, so if you are a student preparing for a GCE A-Level, please I recommend that when you are watching my videos, please I advise that you should look for a pen and a book if possible for you to jot down the relevant points that you will find helpful in the video. Okay guys, so without wasting much of your time, let's dive into it. Okay guys, so the question will be displayed to you and we will tackle the solution step by step. Okay, so the question reads, so the question is from paper 2. So let's read the question 2 Roman 1. Okay, so the question reads, given that the root of the quadratic equation x squared plus 2k plus 2 times x plus 2k plus 5 equal to 0 are alpha and beta. Okay, part A says find the constant k for which alpha equal to beta, and the B part says for k greater than 0 find a quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. Okay, and the Roman 2 of the equation reads find the range of values for which 2 minus x divided by x plus 1 is greater than or equal to 0. Okay guys, so that is the question displayed. So we will be tackling the solution step by step, and as I earlier said, please advise that when you are if you are watching the video, please follow me by using a pen and a book. Okay, so there are some relevant points that you might be jotting down. Okay, all right, so let's get started with the solution. Okay, so solution for the A part. So this we are tackling now the A part. Okay, so this is a question displayed to us. Okay, all right, so this is actually a quadratic equation. Yeah, it's actually a quadratic equation because this is x squared and this is x and this is my constant. So these are my constants. Okay, yeah, so this is the coefficient of x here is 2k plus 2, and the coefficient of x here is just 1, and the constant term here is 2k plus 5. Okay, so you can clearly see that this is our A, this is our B, and this is our C. Okay, so now I will call SRO as my sum of root. Okay, so for alpha and beta, right, so we have sum of roots and product of roots. Okay, so for the sum of root is such that alpha plus beta is equal to negative b divided by a. Okay, yeah, it is such that the sum of root, sum is add now, so sum of root means alpha plus beta is equal to negative b over a. Okay, and equally product of root denoted as p subscript r is alpha beta. Okay, so the product actually means multiplication, so it means to multiply alpha and beta, and that will give us c divided by a. I notice that our a is our a here is 1, our b here is 2k plus 2, and our c here is 2k plus 5. Okay, all right, that you notice that this is it. This is what I was explaining. Okay, so that is it. It is very important. This is that means the coefficient of x here, which is our a, is 1. Okay, because 1 multiplied with x is just 1, is just x now. So, and then for our b, we have 2k plus 2, because this is the coefficient of x here. This is the coefficient of x, which is 2k plus 2. And then for our c, you notice that there is no, this is a constant. Okay, this 2k plus 5 is actually a constant, and that constant is our c from the quadratic equation ax squared plus bx plus c. So this is our c here. Our c is a constant. Okay, so that is it. All right, so since this is our alpha plus beta, which is negative b divided by a, so it means that our alpha plus beta will be equal to negative b. This is our b here, so it will be negative of b, then divided by a. But divided by 1, like taking something divided by 1 is the same thing. So that is why negative 2k, negative times 2k plus 2 divided by 1 is like saying it's still negative 2k, negative times 2k plus 2. So we can call this equation 1. Okay, yeah, we can call this equation 1. I hope this point here is really clear. Since our alpha plus beta is equals to negative b divided by a, so it means where we see b, we put our value of b, which is 2k plus 2, and when we see a, we put our value of a, which is 1. Okay, and then we keep our negative outside. So since our b is 2k plus 2, it means I will keep my negative outside, then I put my b there. Okay, then divided by 1. But since something divided by 1 is the same thing, it means that my alpha plus beta will just be equal to negative of 2k plus 2. Okay, so I can call that equation 1. Okay, yeah, I hope it is clear. Okay, now similarly, our product of roots, which is c divided by a, it means that this is my c. Okay, this is my c and my a is 1. So I will still take my c, then I divide it by a. So this is my c here, c divided by 1. My c divided by a is like 2k plus 5 divided by 1. And 2k plus 5 divided by 1 is still 2k plus 5. Okay, so I can call that equation 2. Okay, all right. So now if, because the question says, or the part even find the constant k for which alpha is equal to beta. Now this part is a little bit confusing many students. Some students, they will say the equation says alpha is equal to beta, not beta equal to alpha. Some students, since their alpha is equal to beta, they are instead solving for, they are instead of substituting beta where they will find alpha, instead of substituting alpha where they will find beta. Okay, so that is it. Now if alpha is equal to beta, it implies that from equation 1. Okay, so if alpha is equal to beta, then what will happen from equation 1? From equation 1, this is our equation 1 here. Our equation 1 says alpha plus beta, okay, which is equal to negative of 2k plus 2. So it means that when alpha, if alpha is equal to beta, it means where I will see where I will find alpha, I will substitute beta in that place of alpha. So in this case, this is my alpha. So I will replace this alpha with beta. Okay, that is why we have beta plus beta. Okay, that is why we have beta plus beta, which is equal to negative of 2k plus 2, and implies that beta plus beta is just 2 beta. Okay, so that is it, and therefore 2 beta will be equal to negative of 2k plus 2. Okay, but there is an important stuff here. Okay, there's some important stuff here. We have 2 here. We can conveniently divide all through by 2 here. But now it means dividing by 2 means divided by 2 here, it means the 2 cancel with this other 2 here. Now how are we going to solve for this other 2 here? It means we are going to factorize, we are going to remove 2 outside. Okay, yes, we are going to remove 2 outside. So at the end of the day, we have 2 beta being equal to negative 2k, negative 2 times k plus 1. Okay, so I've not changed anything here. Yes, it's the same thing. Like if I want to arrive back at this point here, right, I will take negative 2 times k. I will have negative 2k. Okay, and I take negative 2 times 1, I'll have negative 2. Then I'll just factor out the negative outside again for me to be left with negative of 2k plus 2. Yeah, so that is it. So now that I have 2 beta being equal to negative 2 times k plus 1, it means I can actually divide all through by 2. And if I divide all through by 2, it implies that my beta will just be equal to negative of k plus 1. Okay, so this is my value of my beta, negative of k plus 1, okay, or negative times k plus 1. So that is my value of beta. Okay, yeah, so similarly from equation 2, right? So this is the part for sum of root. So now we are dealing now with the product of root, and the product of root is just alpha beta, which is equal to 2k plus 5 from equation 2. So alpha beta, and we know that our alpha is equal to beta. It means where I will find alpha, I will put beta there. That is why I have beta times beta instead of alpha times beta. So I have beta times beta, and we know that beta times beta is beta squared. Okay, so it implies that beta squared will be equal to 2k plus 5 because here we have alpha beta being equal to 2k plus 5, and therefore we have beta squared being equal to 2k plus 5, and we can conveniently call that equation 3. Okay, so that is it. Now we know that our beta is equal to negative of k plus 1. Okay, yeah, negative of k plus 1. So it means, but this is our beta squared. So it means I can conveniently take this beta and I substitute it in the place of beta squared. Okay, so at the end of the day, we will have this. Okay, this is my beta. My beta is negative of k plus 1, and then I have to substitute my beta in the place of beta squared. Okay, it means I will put my beta here and then I square it. So this is my beta. My beta is negative of k plus 1. And then I will square the beta. Okay, so it means I've squared everything here. Okay, but our beta square is equal to 2k plus 1. Therefore, our negative of k plus 1, 2k plus 5, sorry. So our negative of k plus 1 all squared will just be equal to 2k plus 5, since beta squared is equal to 2k plus 5. Okay, now in mathematics, right, if a term is raised to an even power, right, an even power, or let me say if a negative number is raised to an even power, the result is positive. Okay, so I recommend that you should watch the video on where I was explaining this stuff under. Anyways, just go on the YouTube platform and just type MDLFA. You find a video I explain this stuff here. Okay, so that is it. Okay, you notice that when I square a negative number, when I take the even power of a negative number, the result is positive. And therefore, since 2, the power here is 2, which is even, it means if I square this number inside here, I will have a positive number. And at the end of the day, I'll have that k plus 1 all squared. Since I've squared it, right, I've squared it, so this negative disappears, because square means taking this thing 2 times. Yeah, so if I take negative of k plus 1 times negative of k plus 1, I will have positive of k plus 1. Therefore, I will square it now. Okay, so it's the same thing from here to this point to this point is the same thing. Okay, so it's equal to 2k plus 5. Now, k plus 1 squared, k plus 1 all squared is the same as k plus 1 times k plus 1. Okay, so this is it. Okay, so k plus 1 times k plus 1 will be equal to 2k plus 5. Okay, and then I can expand this bracket such that I will take this k and multiply with this 2. I will take this first term here and multiply with this second bracket. Then I take this second term here and multiply with this second bracket again. Okay, so at the end of the day, I will have k squared. I will have k times k squared, and k times 1 1k, 1 times k 1k, and 1 times 1 1. Therefore, at the end of the day, I will have k squared plus 2k plus 1 being equal to 2k plus 5. Okay, so this is a quadratic. This is actually a quadratic equation, this one here. Okay, so now I can just collect like terms here. I can collect like terms. So it means collecting like terms means I will take this 2k and send it inside, and then I take this 5, I cross this 2k, I cross it, I will send this 2k in the other side. Okay, I'll also bring this 5 in this other side. Okay, so at the end of the day, I'll have this. I'll have k squared plus 2k minus 2k plus 1 minus 5. So notice that if a term is crossing the equality sign, the sign changes. So 2k is actually positive. So if it crosses this equality sign, it becomes negative. That is why here we have a negative 2k. Why here we have a positive 2k? Because the positive 2k crosses this equality sign. Okay, so that is it. And equally for the 5, right, we have a positive 5 here. So it means since it has crossed the equality sign, we are going to have a negative 5 there. Okay, so at the end of the day, we have k squared plus 2k minus 2k plus 1 minus 5. And 2k minus 2k is 0. And 1 minus 5 is negative 4. So at the end of the day, we'll have k squared minus 4 being equal to 0. Okay, and you notice that this is an important result known as difference of 2 squared. Okay, so k squared minus 4 is like saying k minus 2 times k plus 2. Okay, so at the end of the day, we have this as difference of 2 squared. Okay, so this is difference of 2 squared, and we can conveniently look for a, okay, for k. So yeah, either k minus 2 equal to 0 or k plus 2 equal to 0. Okay, and implies that k is equal to 2 or k is equal to negative 2. So we have two values, but we have to restrict one of the values. Okay, so it means we go back to our equation. So the equation says, okay, yeah, the equation says find the value of k for which alpha equal to beta. Okay, this is it. So this is our value of k. These are our values of k for which alpha is equal to beta. Okay, now that is it. I hope it is really clear, because we are going now to the b part of the equation. Okay, so it means since they said for k greater than 0, right? So it means for k greater than 0, according to the equation, according to the b part, for k greater than 0, it simply means that we are going to restrict the negative part. But if the equation was for k less than 0, it means we will restrict we will take the negative part and leave the positive part. Okay, but the equation says for k greater than 0. K greater than 0 means that for these two values, right, when we draw our number line, right, we notice that negative 2 is less than 0, while positive 2 is greater than 0. That is why I choose k equal to 2 since k is greater than 0. Okay, so that is it. Now for the b part. And for the b part, I did this because I'm going to use k greater than 0 for the b part. Okay, so the b part say for k greater than 0, find the quadratic equation with integral coefficient whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. Okay, so that is the b part. So we have our new roots. So new roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. Okay, so now we're looking for the sum of new roots. So this is our sum of roots and this is our product of root. So we have to look for, since they have asked us how we should find the quadratic equation, so we have to look for the sum of new root. Okay, the sum of new root is equal to, it means since our sum of root is alpha plus beta, right, it means they gave us this and this, so it means we have to add them for sum of root since we are summing. Okay, so sum of root is, we have 2 alpha plus alpha beta plus 2 beta plus alpha beta. Okay, so 2 alpha plus alpha beta plus 2 beta plus alpha beta. Notice that we have we can just rearrange things here. So we have 2 alpha here and we have 2 beta here, and we have alpha beta and alpha beta here. It means this alpha beta we add to this other alpha beta to give us 2 alpha beta. It means at the end of the day, we have the sum of root being equal to 2 alpha plus 2 beta plus 2 alpha beta. Okay, so we notice that there is this 2 common here. Okay, this 2 is common here. Why did I decide to choose that these 2 are common? This 2 is common because if I factor out 2, right, if I factorize 2 from here, I will be left with alpha plus beta. But I cannot factorize 2 from this other part because I'll be still left with alpha plus beta plus alpha beta, which is not actually, which is actually wrong. Okay, so at the end of the day, I'll have 2 into alpha plus beta plus 2 alpha beta. I choose this idea because I already know I know that this alpha plus beta is my sum of root, while this alpha beta is my product of root. But if I decide to factor out these two here, for me to have 2 into alpha plus beta then plus alpha beta, will be somehow funny. Okay, so I decided to condense it like this. Okay, all right. So but our alpha plus beta is equal to negative of 2 times 2 plus 2, which is negative 6. Now where is this part coming from? Okay, so since we have had our values of k, right, we know our values of k, which is we know our value of k, which is 2. Okay, it is 2. It means that we will come back here, this equation 1, right? So we put our value of k there, which is 2. That is why we have negative of 2 times 2, which, because our k is 2, right? Negative of 2 times 2, then plus 2, this is here, and 2 times 2 is 4, plus 2 is 6, and then the 6 now be multiplied with this negative sign outside here. That is why our alpha plus beta is just equal to negative 6. Okay, so again, for our alpha beta, so this is our alpha beta here in equation 2. So from equation 2, right, it means we are still going to put the value of k, for which our value of k is 2. So it means I'm going to put 2 times 2, then plus 5. 2 times 2 is just 4, then 4 plus 5 is 9. Okay, yeah, so that is it. So it means that with this our values, right, we can actually look for the sum of new root from here. I'll just take these values and substitute them here. Okay, so that is it. All right, so that is it. Okay, so our sum of new root is that, and if we substitute out, or if we substitute the values, we know that alpha plus beta is negative 6 and our alpha beta is 9. Okay, so it means that my sum of new root will be 2 times negative 6 plus 2 times 9. 2 times negative 6 is negative 12. 2 times 9 is 18. Negative 12 plus 18 will just give us 6. Okay, that is our sum of new root. All right, so let's move now to the product of new root. So our product of new root, p of p subscript n, is just equal to product of new root. Product means we are actually multiplying. So it means that since this were the integral, the integral. So since these were the integral root that we're given, so we have to expand them. Okay, so we have 2 alpha times 2 beta. It will give us 4 alpha beta. Okay, yes, 2 alpha times 2 beta will give us, because 2 times 2 is 4, and then alpha plus beta is alpha beta. Okay, okay, all right. And then we move to this other part here now. So we take 2 alpha again, then multiply it with alpha beta. Okay, so we'll have 2 alpha squared beta. Okay, because this alpha we multiply with this other alpha for us to have alpha squared. Okay, and then the beta. Okay, that is why we have 2 alpha times, that is why 2 alpha times alpha beta is 2 alpha squared beta. Okay, then we continue to the other part. Now we have alpha beta times 2 beta. This beta we multiply with this other beta to give us square. Okay, and therefore we have 2 beta squared alpha, or 2 alpha beta squared is the same thing. And then we have alpha beta times alpha beta is just alpha beta all squared. Okay, so now I decided to align this part in red because I'm going to work with this part now. Okay, so attention is needed here, please. Okay, so we have 4 alpha beta, right, plus 2 alpha beta into alpha plus beta. So what I've done here is that let's come back here. So we have 2, which is common, right? So this 2 here is common. So 2 is common, and we have alpha here and alpha here. Okay, yeah, we have alpha here and alpha here. It means we can remove one alpha outside, so this is the alpha outside, and again we have beta here and 2 betas here. Okay, so it means we have beta here and we have beta here, so we can remove one of the betas outside. Okay, so at the end of the day we have this, like I factorize 2 alpha beta outside, such that if I multiply this I will still have this. okay, because 2 alpha beta times alpha will give me alpha squared 2 alpha squared beta, which is this, okay. And similarly for this other case is this, okay. So it means for me I've just factorized 2 alpha, since 2 is common, alpha is common, and beta is common, so I've just factorized 2 alpha beta outside, okay. So that is it. Now notice that alpha beta is product of roots, which we had as 9, and alpha plus beta is -6, okay. So at the end of the day, if we substitute our value, so we have 4 times 9, which 9 is alpha beta according to equation 2, and then plus 2 times 9, then times -6, since alpha plus beta is -6, okay. Then plus alpha beta, which is 9, then we square it, okay. So at the end of the day, we are going to have our answer as 9, okay. Because if we punch a calculator, so let me just punch it out. So I have 4 times 9, which is 36, plus 2 times 9 times -6, plus 2 times 9 times -6, which is -72, okay. Then plus 9 squared is 81, plus 81, so we have 9. So that is our value of product of new root, okay. So the new equation will always be in the form, so in this theory of alpha and beta, right, if you are asked to form a new equation, just know that the new equation will always be of this form, okay, where Sn is our sum of new root and Pn is our product of new root, okay. So this is the new equation: x squared minus Sn times x plus Pn equal to 0, okay. So if you substitute these are values of these are value of Sn and our value of Pn, it means that our new equation, our new quadratic equation, will just be x squared minus 6x plus 9 equal to 0. The minus here because there is a minus here, okay. So our Sn is just 6, not -6, okay. And therefore this is our new quadratic equation as required, okay. So that is it. All right. So let's move to the Roman 2 part of the equation. The Roman 2 part of the equation says, find the range of values for which 2 minus x divided by x plus 1 is greater than or equal to 0. So this part here too is this question is from this Roman 2 part is from inequalities, okay. Inequalities is also an essential topic in mathematics, okay. So let's look at the solution. All right, so questions of this nature, right, just look for the zeros, okay. It means we look for the zeros here. It means that is looking for the zeros means you take the what is in the numerator, you equate to 0, and then you look for the value of x, okay. Similarly, take what is in the denominator and then equate to 0, then look for the value of x. I notice that these are the critical values, okay. These are the critical values, okay. So hence negative x equals to 2 and x equals to -1 are the critical values, okay. But there is some important thing I wanted to give you guys here. There is one important thing, because yeah, most students here will want to cross multiply. They would like to cross multiply. So this is actually wrong, because we cannot cross multiply, because we don't know if this x plus 1 is actually positive or negative. Because if this if the equation was if the equation specified that x plus 1 is always positive, it means that you can conveniently cross multiply, because this won't change the equality sign. But now we don't know if this x plus 1 is positive or negative, okay. That is why you cannot just cross multiply like that, okay. So it's better for you to look for the zeros, okay. It will be better for you to look for the zeros. So for the zeros, it means you equate the numerator equal to 0, then you look for x, and similarly for the denominator, then you look for x. Okay, so these two values, these are our critical values. Okay, so that is it. Now we are going to look for the sign table. Okay, the sign table means we are going to look for the values, the range for which this equation is greater than or equal to 0. It means we are not considering the negative part. We are considering the fact that it should be either greater than 0 or equal to 0. Okay, so that is it. Now if we draw our sign table, right? So from these two critical values, right, it means we'll be looking at 3 intervals. Okay, 3 intervals. Yeah. Okay, so if we draw our sign table, so we have this first interval, the second interval, and the third interval. Okay, so now we have -1 to 2. So if we consider -1 to 2, it means we are going to put -1 here and then we'll put 2 here. Okay, since -1 is smaller than 2. Okay, so it means here we are going to place the -1 here and we are going to put our 2 here. I can conveniently see that in the middle we might have 0 within this range here. Okay, between -1 and 2 we might actually have 0 there. And just from this fact that between -1 and 2 we might actually have 0, it means that the solution actually lies within this range without even necessarily looking for the negative, whether it is defined, whether it's positive here or here or here. Okay, just from within this range we can conveniently see that between -1 and 2, 0 is between them. Okay, but anyways, it's good for us to look for the region where this equation will be defined. Okay, all right. So this is our -1 and this is our 2. So now here it means we are going to look for the values of the values that are it means how can I put it? It means for me, right, we are going to take any value which is smaller than -1, and then we substitute here for us to verify if it is positive or negative. Okay, so values that are smaller than 1, okay, it means values that are going away from -1. Okay, in the left direction. Okay, so if we look at those values, it means that we are going to write x less than or equal less than -1. Why did I put it like this? Because I'm looking for I'm taking values of I'm taking a value that is smaller than 1 in the left direction. Okay, that is why I decided to put x less than, where x is that value. Okay, where x is that value. So the value that I will choose -2. Okay, so if I take -2, right, if I take -2, I put it here. So I have -2, I have 2 minus 2, which is 4, right, which is positive, divided by, I'll put -2 here. So it will be -2 plus 1. -2 plus 1 is -1, and therefore positive divided by negative is negative, and therefore this region here will just be negative. Anyways, let me just, so I've divided my range into 3 parts. Okay, so this is the first part, this is my first region, this is the second region, and this is my third region. Okay, so these are values of x. These are values of -1, which are to the left of these are values of x which are to the left of -1, and these are in this second region. It means we are looking for values of x which lie between -1 and 2. Okay, and here values of x which are far from -2. Okay, so it means far from -2 is like, you can take 3, 4. So there is an important stuff here that I want to explain. Anyways, I'll explain it when I will be done with the solution. Okay, so for me, if I take -2, right, I put it here. I will have 2 minus -2, which is 4, which is positive. Then here is negative. So if I put negative 2 plus 1 is negative 1. So positive divided by negative will just give me negative. And therefore, all this part like this will be negative. Okay. So this part here is negative. Okay. So now, I'm done with the first region. Now I'm going now to the second region. The second region means I'm going to look for values between negative 1 and 2. So it means values between these two values are, we have 0 and 1. Okay, we have 0 and 1 actually. So it means I'm going to take 0. If you can still take 1 or 0, it's still the same thing. So I'm going to use 0. So if I put 0 here, 2 minus 0 is 0, and I put 0 here, 2 minus 0 is 2, sorry, 2 minus 0 is 2, and 2 is positive, right? And then I put 0 here, 0 plus 1 is 1, 1 is positive. Therefore, positive divided by positive is positive. So it means all this region here will be positive. Similarly, if I use 1, let me take 1, okay? So 2 minus 1 is 1, okay, which is positive. 1 plus 1 is 2, which is positive. Positive divided by positive is positive, okay? Therefore, this region will all be positive, okay? That is it. Now, for values of x far above 2, right? So it means we can take 3. Okay, you can take 3, 4, 5, 6. It depends on you. Okay, it depends on you. All right. So if I decide to use 3, right? If I use 3, let me use 3, yeah. Or you can still use 2. It depends on you. You can still use 2. Yeah, you can still use 2. Because this is a region where this function is totally positive. This is a region that makes this function be this equation to be positive. Okay, so but I will decide to use 3. Okay, if I use 3, right? If I use 3, I put 2 minus 3 here, which is negative 1, and 3 plus 1 is 4, which is positive. So negative divided by positive is negative. So all this region will be actually negative. Okay, so that is it. Okay, now from this sign table, it means that we notice that this region does not satisfy this condition here. So this other region too does not actually satisfy this condition here. Okay, because this region is negative and this other region too is still negative. So it means this is the required region, and therefore the range or the solution set of this equation here is such that x should lie between -1 and 2. Okay, so there is this important stuff here. Some students might be asking why I didn't use less than here and also less than here. There is a reason for that. Okay, if we decide to use a less than here and here, or strictly less than here and strictly less than here, right? Let me just explain the reason. The reason is because if we come back here, right, if we put when x is 2, right, these are x here. When x is 2, it means this part will be 0. It means this part will be 0. Okay, yeah, but this part being 0, this part, okay, where is it? This part being 0, right? So this part being 0, it means that the function is actually defined here. Okay, the function is defined because the condition is this should be greater than or equal to 0. So it means if I put 2 here, right, 2 minus 2 is 0, right? And then 2 plus 1 is 3. So 0 divided by 3 is 0. Therefore, this part here is actually defined, and therefore this part here is included. This 2 is included. Okay, this x equals to 2. 2 is actually included in the range. Okay, because it actually makes this function to be this equation to be defined. Okay, since the condition is talking of this function being greater than or equal to 0, it means it should be 0 or it should be greater than 0. Okay, so it means if I take 2 minus 2 is 0. 0 divided by any number, say 3 here, is still 0. It means this part is actually included. That is, if something is included, right, it means you write a greater than, a less than or equal to, or a greater than or equal to. Okay, so that is it. So in our case here, s lies between -1 and 2. Since 2 is included, it means because 2 actually make this function to be defined. Okay, at x equals to 2, this function is actually defined, okay, or this inequality. All right, so why did I choose to use the strictly less than here? Because if x should be strictly less than 1 here, because less than -1, because if x is -1, this function will be undefined, because if I put -1 plus 1 is 0 and take any number divided by 0, it will be undefined. That is why x should not be -1. X should be strictly greater than -1, means that x should be any number but not -1. Any number greater than -1. Okay, so that is it. Because if it is -1, then this function will be undefined. That is why I include values of x between -1, x strictly greater than -1, and x greater than or equal to 2. So that is it. All right, so this is the end of the video. Please, this is my question here to you guys, that was the video helpful? So if you find the video helpful, please don't forget to subscribe and like, okay, and if possible you can even share to your friends too. All right, see you in the next video.